Morning. My name's Elliot Bell. I'll go through some of these slides fairly quickly so that I could get to some of the more interesting ones. I've been at this for a while. That's what that says. Okay, I've been at it for a while. So I am a member of Georgia Pacific's overall team. We have 3 major divisions within Georgia Pacific. We are a wood products company. Packaging and cellulose creates bleached board, cellulose, corrugated, different types of paper. The building products group creates building products, wood, plywood, gypsum, strand board. Consumer products is your typical tissue, which some are in the restrooms here. Everything from Angel Soft to plates and just our consumer products that we use on a daily basis. So in a company this size, we have varying problems that we're worried about. And as we think about KPIs and we think about how we go through a transformational process, which is what we're doing now, the problems are multivariant. It's not just a single problem. It's not just, hey, I can go fix this one thing and improve my uptime or improve my business overall. So we started off with improving safety and excellence, which is always first for us. Ensure environmental compliance and be a good steward of the resources that are allowed to us to use. Increase customer demands and expectations. Of course, we need to meet and exceed our key shareholders' expectations. Got to be profitable, right? Just makes sense. There is an expected shortfall in human resources going forward. So how do we prepare for that? So I'll show you how developing key KPIs and improving uptime, improving business performance actually will set us up to be better positioned to deal with the shortage of human resources. Overall, we want to improve our relative competitive position in the market, which brings us to operations reliability. Okay, the better you run, the happier everyone is. You get to go home on time more often. See the guys in the front and like, yeah. And keys to this, and you've heard it from the first 2 groups, we want to minimize operator intervention. And I want you to think about that. The number of human clicks, the number of human touches is some of the most difficult things to deal with because it is very, very difficult to be disciplined from one operator to the next. So the more you interface or the more interfaces you have, the harder you have to work to maintain that discipline. You've heard a lot about data. So the measurement and control information systems, our mills are on average, call it 50, 55 years old, on average. We have some that's 100. Our youngest is like 27. Okay, so we have some significant assets. Most all of our mills have DCS systems. Some of them are still running version 1. Some of them are running version 2. Some of them are running version 7. Okay, the ability to get data out of those mills is challenging. It's no different from the groups before me or the presenters before me. There are high challenges to moving data. It just always has been, and it will be. But all of that leads to, when you think about the human intervention, you think about the data capture challenges, you think about the use of data, it comes down to high process variability that leads to off-quality products, higher cost, lower productivity. So how does that really impact us? Well, we have a facility maturity mental model. And that mental model is what's driving us forward in how we develop where we're going, our strategies, and our expectations. We had variable results. Let's be serious. 10 years from now, we will have completed this process, and we'll probably still say we have variable results because the horizon will have shifted. So, this is the older one. Capabilities. We want to become more capable. What does that mean? That means that capable does not mean we're perfect. It means we are better than we are. We can somewhat control our process, right? How do we become more capable? We instill a disciplined workflow, period. So we have what we call playbook. Playbook would be also thought of as a lean manufacturing kind of mindset. We know where people are supposed to be. We know what they're supposed to do. We measure and check on a daily basis to make sure they're doing what they're supposed to do. We want to have alarm management systems so that we understand where we're getting flooded and what's going on within our process. Our CLIP program allows us to measure on a routine basis how our process control systems are performing. So we look at the total loop counts within our facilities, and then from that, we look at how they're being used, how well they're controlling the process, whether there's stiction. It's just a huge analytical process. That drives us to capable, which allows us to have better control. Within that, we are moving towards standard instrumentation and the installation of advanced process controls. Okay. Whew. No, that was the bottom button. That was actually the bottom button. Stable, so capable to stable. Stable gets us to the point of having a general idea of what to expect all the time. Okay, again, it's not quite perfect, but it is mostly predictable. We are in control of our process. At capable, you're not necessarily in control of your process, but you can get days and times when your process runs where it wants to, but you still have unplanned events. You're not quite hitting your production numbers. To go from capable to stable, one of the big things, or two of the big things that we're introducing is remote monitoring and a heavy use of analytics. I'll come back to those in a second. Where are we trying to go? We're trying to go to predictable and efficient. Predictable, optimization is widespread. We have continuous reliability achievement at a high rate, and we know where our process is going to be, and we control where our process is. How are we going to move from stable to predictable and efficient? We have what we call daily operation centers, which means we're moving away from the historical use of 10, 12 control rooms spread across a facility. If you guys haven't been in a paper mill, most of our mills are integrated paper mills, anywhere from 300 to 1,000 people per site, multiple control rooms. Historically, each control room was a separate kingdom. So we're really tearing down the walls of all of the separate kingdoms, trying to move them into one central place where all of the operators work well together. So the question is, why are we doing that? We're trying to drive OEE higher, and we're trying to drive OEE higher in order to get to a point where we're making more money. So in this, what you see is at the very top, we're operator-centric on the left-hand side. We're operator-centric where we have variable results. As we go from variable to capable, stable, and predictable and efficient, we move more to a monitor-centric, fewer clicks by the operators, fewer interventions by the operators, more profits for our key stakeholders. We said we are monitoring and using analytics. We leverage big data, and I hate the term big data. We leverage data. Okay, big data makes it sound like it's new. No, we changed our mindset to go get all of our data. Why? Because things are hidden. There are Easter eggs hidden all throughout the process that you never know if you don't have the data. Think about it. You have operators that you pay, and you encourage them to make decisions to manage your business. Who's checking to make sure they're making the right decision? Who's checking at where the waste is coming from and how you get rid of the waste? So, what is our mental model to increase this? I'm going to blow through this one for 1 second. We actually did not go bottom up. This is actually a top-down mindset. The top-down mindset is from a upper level, we need to have one source of the truth, one set of data that's shared all throughout the corporation. Why? Earlier, and it was funny because when he said this, I was like, he stole my line. If you're looking at one meal, it's great. And you're usually really knowledgeable about what's going on in that meal. If you're looking at 10 meals, it's kind of harder to keep up with. And I don't necessarily want to say people lie, but let me just say this. If you can't tell where the mistake was really made, I might not volunteer it. Just saying. You can tell the machine is down. Why the machine is down may be adjusted in my history. Now, it's not what we do now because we are very high in integrity. But in my history, I'm only going to volunteer what absolutely is necessary. And blame another department. No. I'm only going to volunteer what is absolutely necessary. So how are we doing this is we have created a dashboard system with business KPIs. Now, I would be remiss to say these two things. A KPI is not simply data. Data is data. A KPI is an analysis that allows you to make a logical conclusion from data. If you drive your KPIs higher, your business will improve. You can fix a KPI, but if you have a operator, we heard centerlining earlier. You have an operator and he drives his centerlining target exactly on target, and it's the wrong target. Your KPIs won't change. Matter of fact, one of the things we've seen quite often is we have started using things like wireless vibration sensors to tie our process together. As we now use wireless vibration sensors, what we have started doing is tying that to process data. And what that has shown us is quite often we would drive our process to its centerline value, which would drive our equipment into a critical vibration state and end up wrecking equipment because we were running within a centerline point. Centerlines by itself may be what we used to, but you have to integrate all of that data into effective KPIs. So what we did is we created KPIs at our highest level. We have corporate level dashboards. We have mill level dashboards. The mill level dashboards tie into area level dashboards. The area level dashboards tie into historical data collection systems. So how does all of that look? This would be our division level dashboard. So you notice no numbers. Why no numbers? Anyone? No, unfortunately, our leadership loves numbers. They also love getting way down in the process. Okay? So what we are trying to change our mindset to is to go to where we need help, not necessarily what emotionally we are tied to. So if you look at this screen, and I know this just because I'm close enough to it, the top two are OEE, or uptime and production. The bottom one, very bottom one, is environmental. The one not showing bottom left is safety. If you see a mill that is red in the middle, that means that that condition has existed for 3 days. So then you kind of think through, where do I need to go? As a senior VP, this is trying to help you quickly figure out where to go without having to go, hey, okay, so I see a number. So is that number where it's supposed to be? Is it a little high? Is it a little low? Okay, so that's a whole lot of analysis that's already built in here. So if you then drop to a mill, this is one of our mill dashboards. This is what we call the operations dashboard. That is a breakdown of all of the key areas of that mill. You may notice on the left-hand side, you see the OEE charts. We break down OEE per area. And then as you notice, as you look across, we break down OEE. It is the top KPI in every area. So we break down OEE by each piece of equipment. The reason there is OEE is our target KPI. Why? Because we have extremely complex systems that we're trying to combine all of those extremely complex systems into a single KPI that can help us target where to go work. Now, beyond that KPI, we do start to give some production data that we change to percents. We give some key data that the area leaders have asked for, but we always come back to that key KPI. Then we get to an area level. At the area level, again, OEE by equipment type and total OEE for the area. Then you see individual equipment groups, so power boilers, turbine generators. The system, this project continues, so then you get into DMIN systems, air compressors. The key is to be able to alert our leadership to the focus area where they're having trouble as quickly as possible. And we have other systems that back this up. This is one system that is being built to tie all of our existing systems together. So, results. We're trying to be more competitive. We can no longer afford to solve problems through brute force. And that's what we've done for years. We would come in, and if we were struggling from a reliability standpoint, it is we're going to put more people on, or we're going to put people on 24 hours a day, and we're going to overwhelm the issue with manpower. Our belief is the manpower will not be available long-term to continue that process. So we are trying to rely on analytics and KPIs to identify issues and to drive us forward. It is early, but we are pleased with the direction we're going. We have in-house analytics have provided significant opportunities and delivered acceptable results. We have a team of data scientists that are doing some really incredible analytics that continue to propel us forward. Data governance, ooh boy. we have multiple facilities. More than half of our facilities were acquired through purchase. Therefore, their data systems are not the same as other data systems. Naming conventions, how you do a calculation, where the data is sent to. All of these are concerns that have to be addressed to truly be effective. And the more uniform your data is, the more effective you can be in using your data to generate KPIs. Remote monitoring and optimization support is providing transformational foundation. They use the KPIs to direct them to issues that they go to facilities to address. And the use of a standard KPI like an OEE, huge. The one last thing, like I said, key process variables are process variables. They are not KPIs. You kind of, if you're really trying to move your business, you have to understand what are your KPIs, which are usually something that you cannot simply go measure. You know, you can calculate it, you can use a lot of algorithms, but most of the time, your key KPI is going to be something that is more of a calculation than a measured number. And that's it.